Hi everyone. So my name is Marin. I am the sales representative of the Benelux and Ireland. And so together with Manuel, we will presenting you a webinar about the risk and the evaluation of risk in the laboratory. This is a very interesting topic, which is always coming back when we meet customers, when we see people like you in the lab. We talk about the risk and the appropriate laboratory solutions, safety solutions, in order to minimize the risk. It's great to see you all connected. I just wanted to say that we are really very, there are a lot of people connected. We have more than 24 nationalities from all around the globe connected, so this is really a good opportunity. And of course, we're going to talk about risk in the lab, but of course, everyone today is exposed to another risk, which is the coronavirus. So this is a great opportunity to help to do this webinar and to explain you a bit more in detail what risk is in the lab. So let's go ahead and start straight away. So of course, the first subject will be when is there a risk? Secondly, how to evaluate the risk, and the third subject will be the safety solutions. These are very obvious themes, you might think. When is there a risk in a laboratory? How do we need to evaluate it, and what are the safety solutions? It's just very important that when you are working in a laboratory in an environment where there are chemical hazardous products that you work with, that you are going to look for where is that risk situated exactly? What's the source of the risk? How do we evaluate that? Because there are certain methodologies that you can use in order to look for the best way, the best solution that you can help to minimize that risk. So these are the things that we will discuss in this webinar. And of course, the first thing that we ask ourselves, when is there a risk? And that's very simple. Because what is the biggest risk in labs? It's chemical hazardous products. So these can be toxic, these can be aggressive. These are products that we are exposed to and that are harmful for our health. So when you have these products and where you're exposed to them, then simply we talk about risk. Then you are exposed to a certain risk. But what's the level of that risk? A very important thing to ask. Is the level very high? What's the danger of the product that you're using? So it depends really on a few different aspects. It's related to the type of chemical that you're using, the type of handling. What are you going to do with the product? Are you just going to store it? Are you going to transfer it? Are you going to heat it? All different things that will impact the risk that you're exposed to. And of course, the duration and frequency of use as well is very important to take into account when you talk about risk assessment in the lab. So just to give you a quick example of different levels of risk when you're exposed to something. Take, for example, a bottle of acetone. It's closed in a storage cabinet. Of course, the risk that you're exposed to is very low. You will only be exposed to a very low amount of chemical vapors when you open the door of the storage cabinet, so the risk is very low. However, if you would fill in a beaker with acetone, you will pour the product into a beaker, so there is evaporation, so the hazardous or the risk will be higher. So then there is higher risk, and if you would heat acetone, the risk will be even more present. So context is really important when you talk about risk assessment in the lab, and we talk about chemical hazardous, but that's quite obvious, I think. This is an important something really important that I wanted to share with you guys. It's a European regulation, so there are many different regulations involved to risk in the lab, and you can see here three points for European regulation, but also 2 links to know more about risk in the lab and what the regulations really are in Europe. Of course, there are many people as well connected from the Philippines, from Indonesia, from Asian countries. So it's also interesting for you to go and have a look at the regulations in your country about exposure to chemicals. But this is really a good a good way to compare. Okay, what is the risk that we are exposed to? General rules of prevention. So how can you evaluate the risk, but what are the general rules of prevention to chemical hazardous? Of course, the first thing that you have to think about, if we can avoid the risk, remove it. Remove the risk if possible. Don't leave a bottle open when you're not using a chemical. Close it and avoid the risk in general. Of course, you need to evaluate the risk and avoid it from the source. So it doesn't make sense to go and look for a solution at the end of the chain. No, go and look for the source. And in most of the cases, it's just the chemical product itself that you have to look for. Substitute when possible. That's also very important. If you can use a product which is less harmful for the user, for the people in the lab, replace it as simply as that. So for example, CMR products, if you can replace them by another chemical which will react in the same way, then that's a good thing to do. And then you can always look for the good solutions. So technical, but also organizational, you can look for different solutions which will minimize the risk again. So you need to favor collective protection instead of personal collection. A really good example to give is we are all confronted with the coronavirus. A collective protection that we all take into that we're all doing today is that we are going to wear masks when we go onto the street. A personal protection would be that you stay at home and you don't go out. So you stay at home. So that's an example of minimizing risk. That's in general about the coronavirus, but that's also applicable in the laboratory as well. And of course, another general rule of prevention, how can you prevent a risk in the lab, is of course ensuring training and information to the people in the lab, and doing that frequently as well. Not once, not twice, but on a regular basis. But let's talk more into depth about the theoretical things that we can compare or that we can use in order to minimize risks. So we talked about the general rules in Europe, for example. There are general rules, but what are those rules? What do we know? So if you talk about chemical hazardous, you can talk also about the limit or the exposure limit values that these chemical products have. These exposure limit values, they are regulated by each country, not always by Europe itself, but by country. And you always have two values. You always have one on the short term and one on the long term. So often the one on the long term will be higher than the one on the short term. So there is an immediate risk, or there is an average or long risk on the long term. So these are really important values to look at. And here you have an example of a few products. We have 6 products, some with high limit values and some with low limit values. It's important when you do a risk assessment in the lab to have a look at those. It's just to tell you that when you have a product such as formaldehyde with a very low exposure limit value, the product is very dangerous. So once the exposure limit value is low, such as 0.5 ppm, which is parts per million, the risk will be higher because it's a dangerous product. If you have chemicals with a higher limit value, of course these are also hazardous and dangerous for your health, but you can be in theory exposed to a higher quantity of these products. So that's a really good way to look at, okay, what do we have, what are the chemical products that we have, and what's their level of dangerosity or danger. So for your information as well, where can you find more information about limit values? So there is a list, European list, and as well, again, for other countries that are not European countries, of course, it's important to have a look at what your country says of each product. Of course, keep in mind, when you do a risk assessment in the lab, this is a really good way to check the danger of a chemical. However, you don't want to be exposed to any chemical vapor. So minimizing the risk in any possible way is always recommended. If you would like to have the website, the links to the website, send us an email after the presentation. That will be greatly appreciated, and we will send it to you with pleasure. Next to the exposure limit values, there is another aspect that we can use in order to know if a product is dangerous, or if a product, what's the identity of a chemical product that you're exposed to. It's the CLP, or the safety data sheet. So the safety data sheet is very known for most of the chemicals that are used in labs. They have this type of identity. And this is European. This is regulated by Europe, and you can read actually what the product does, what it will do to your health, what the danger of the product is, etc. So this is also a really good way to know, of course, what you need to do and what products you're using, and how do you need to store them, etc. So of course, this is something I imagine all of the people connected to the webinar know. These are pictograms that we see all the time when we work in the laboratory, but sometimes they're forgotten, or they are not really taken into account when you work with products. Just to give you an example, how can you minimize the risk when you work with flammables? By storing them in a fireproof storage cabinet. So looking at these hazardous pictograms, you know what the risk is, and you need to look for the appropriate safety solution in order to minimize the risk that you're exposed to. And then I would like to talk with you about the methodology of risk assessment. So this is quite a slide with a few things that are on it, but let's start on the left of the slide. It's a methodology to look at, okay, how can we, what are the risks still present in the lab? Which risks have we eliminated, and which ones are still there, and for which ones do we still have to find the appropriate solution? So on the left part of the presentation, you see identification of products. That's the first thing. You take the exposure limit values of the products, you take the safety data sheet, and you identify the different chemical products that you have in the lab. So you collect information in general. When you've done that, when you've collected all the information that you have in the lab, you do a gross risk assessment. A gross risk assessment is actually making a list of all the different risks that you're exposed to. So you take all the different chemicals, but you're also going to write down, what are we going to do with these chemicals? What are the different manipulations? What are the quantities that we use? The frequency of use, etc. So you really get a clear idea of what are the different things that we do in the laboratory, and what are the different harmful products that we are exposed to. Then you can do a net risk assessment. A net risk assessment is actually the assessment of making the calculation. Okay, we have all these products that we are exposed to, which are dangerous for the people in the lab, and then we have all these products that prevent us from these harmful products. So we know exactly, okay, this is danger, and this is what we use as a prevention measure. And then you're going to deduct in general. If that would be possible, that would be great. But you're going to look at, okay, this is the danger that we have. These are the prevention measures, and then you look at what is the risk that still remains in the lab. And then you make a ranking of the significant risks that still remain. And of course, obviously, afterwards, you make an action plan. When you make an action plan, one of the things that could be in there and is really recommended by us as a supplier for safety equipment is to do a substitute, or to use substitutes instead of the CMR products. CMR products, of course, for the people who don't know, these are very hazardous products that are dangerous for people in the lab, and that can cause cancer, for example. So if you can use other products that are less harmful, please do so. And then, of course, when you make that action plan, you have two different possibilities, and that's what we're going to talk about also in the next slides. You can make a technical investment, so a safety solution in terms of enclosures products, and you can improve your organizational methodologies or organizational things. So very important, what is the thing that we can do immediately, straight away, like let's say tomorrow? It would be the improvement of the organization. It doesn't cost any money, but it's just a question of making sure that you give the right training to the people in the lab, that you give the right information, and then you monitor the safety equipment that's already present in the lab. If we talk about technical solutions, so technical equipment. More in depth about those things, so technical equipment safety solutions, there can be an over and an underestimation, which is very frequent when we visit laboratories ourselves. We see often that people have many different hoods that are not always used, or not always used for the application that they're supposed to be used. They're not always the good practices. So there are many different things that result in the fact that there is an overestimation, so an overinvestment in technical equipment, which can result in, for example, energy and high energy costs, or there can be an underestimation. People who have a routine in the lab, and because they have that routine in the lab, it will cause them problems because they're exposed to chemicals, but they're not aware of it. So an underestimation or an overestimation. Being in the middle is a difficult exercise, and that's why we do this risk assessment and why we do this webinar as well. To give you an example, this is a lab in which you have different types of equipment. You have a canopy hood, you have a mobile fume extractor, you have ventilated benches, ventilated enclosures. But is there really an enclosure? Is there really a containment for the people who work in the lab with the chemical products? So the thing that we ask, or the problematic, the question that we ask is there a barrier between the operator and the product? Is there an air barrier between the people who work with the chemicals to make sure that they're not exposed to these risks? So in general, there is a limited protection. This is another lab, but this is a lab equipped with different fume hoods or different ventilated enclosures, which make sure that you have that air barrier. So it's really a question of asking yourselves, this is a risk we are exposed to, and what's the good solution that we need? And in most cases, it's just making sure that there is a barrier that's not visible, unfortunately, between the people in the lab and the risks that you're exposed to. So to give you an example, this is a lab in which you have ducted fume hoods, but also ductless fume hoods. So the people work in a ventilated enclosure, and you have also a fireproof cabinet, which is connected to a ventilation system as well. Or you have a ventilated storage cabinet, which works on with filtration as well. So there is a good containment, which makes sure that you minimize the risk in the lab. Now, why ventilated enclosures? So as I just said, it creates an air barrier between yourself and the chemical in the fume hoods, let's say, as an example. So that's very important in the first place. Afterwards, you have a second step. When you have these chemicals in the enclosure, for example, you need to evacuate them. They need to go away. So the risk that you have needs to be minimized by eliminating the chemical vapors that are coming free. So they must be contained by a certain mean. So you have the air barrier first, but then you also have, for example, an extraction to the outside air. So you're going to extract the chemical vapors, or you are going to capture them by using, for example, activated carbon filters. So first of all, you look for a containment, and secondly, you will look for a way to capture or to evacuate the risk, so the chemical vapors or the powders. So what are the different ventilated enclosures that we can offer? Or what are the different possibilities in terms of safety solutions? These are collective protective equipments. As I said in the previous slide, when we talked about the methodology, they are collective protective equipments, and these are the best means of equipment instead of personal equipment, instead of personal collective equipment. That's also important, but of course, when you talk about risk in general in the lab, you need collective protective equipment. So these are some examples. You have ducted fume hoods, you have ductless fume hoods, storage cabinets, of course, biosafety cabinets if there is a question of microbiology. You have glove boxes, isolators, but you also have other safety equipment like articulated arms, etc. So it's really important that you know which equipment do we need according to the risk that we're exposed to. If we go into depth into two of the safety equipments that are used the most frequently in labs, then we can tell you a bit more about those. So let's start with the ducted fume hood. A ducted fume hood is a fume hood in which you will work with chemicals and the air will be extracted to the outside. So all the chemical hazards that are coming free in the lab, they will be exhausted by a ventilation to the outside air. So there really is a mechanical ventilation, and you really need to connect that hood with a system in the infrastructure of the building. What is really important and really something that I would like to tell through this webinar is the fact that often we think about risk assessment only the risk that we are exposed to in the lab. When we talk about risk, there is not only a risk in the lab, there is also a risk outside the lab. All the air that we extract to the outside will be released in our atmosphere. So there is also a risk outside the laboratory. So that's also important to take into account. And it's also an awareness that people need to have when choosing the adapted safety equipment. Of course, the risk in the lab is not completely gone when you use ducted fume hoods. You will exhaust the air to the outside, but then you have to pull clean air back into the laboratory through an HVAC system, and that air will be heated again or cooled again, which will result as well in a high energy cost. So a ducted fume hood is a good solution. It will keep you safe. Yeah, it's important it's an important safety equipment that can be used, but it depends again on the risk that you're exposed to, and you need to know what to use. So I just realized there is a short delay in the slides, so I'll try to go a bit slower when I start my explanation. So I will still talk about ducted fume hoods, but on the next slide, that will maybe appear for some of you in a few seconds, you will see some European standards about ducted fume hoods. Ducted fume hoods, they need to be tested in many ways. The European standard for ducted fume hoods is the EN 14175, and I'm sure that many of you know this standard, but there are many different tests that have to be performed in order to assure the safety, in order to minimize the risk. And so we're going to talk more about part 3 of this standard, which is about containment, a test that we perform about containment. So a ducted fume hood, for the people who don't see the slide, normally it should appear just in a minute. The principle of a containment test, which of course creates that air barrier, is by releasing some chemical products. In this case, in the standard, it's SF6, which is hexafluoror. It's quite a heavy chemical. It's released in the enclosure, and we will check, or we will control what the amount of that chemical is that is still coming free in front, so in the opening of the front of the fume hood. So that's something we're going to test in order to assure a good containment. So there are multiple protocols. There is an internal plan, external plan, in order to test this. So to sum up, a ducted fume hood, the big advantage of a ducted fume hood is the fact that you're not limited. If you use large quantities of chemicals, they will all be evacuated to the outside. Of course, you have to think about the fact that it's not really a green solution, because you extract all these chemicals into the atmosphere, but sometimes there is no other solution, and you need to use a ducted fume hood in order to be safe, to be working safe in the lab. So that's really a good example, a good advantage of a ducted fume hood. Inconvenience, however, of ducted fume hoods is the fact that they consume a lot of energy, because you need to compensate the air. All the air is extracted to the outside. You need to recompensate that by air that's coming back into the lab, that has to be heated again, that has to be vented, that has to be cooled again. So you really are consuming a lot of air, which is very high energy consuming. And of course, it's not really a flexible solution. You're fixed. The hood is a fixed ducted system. The other solution, one of the safety solutions that we saw in the list in order to prevent people to be exposed to hazardous chemicals, is a ductless fume hood. And a ductless fume hood works in a different way. A ductless fume hood is an independent system that you can place on, for example, your lab table, and it will recycle the air. It will not consume any air compared to a ducted fume hood. So it will only use the air available already in the lab. And then you ask, of course, the question, where do those chemicals go? Where do those chemical vapors go? Well, they will be adsorbed by an activated carbon filter. If you would use powders or particles, they will be captured by particulate filters such as a HEPA or an ULPA filter. So this is really completely different technology, which has a lot of different advantages compared to a ducted fume hood. But the main principle is that it keeps you safe, again, by a good containment. Just to give you an idea about the different standards, again, that these ductless fume hoods, are exposed to or that they use. Of course, there is one standard that is the most stringent one, which is the French standard. It's AFNOR NFX 15211. And then there are a few international standards as well, which is one for England, for China, and for the US. There are some people from the US who are as well connected. This may be one of the rules or the international standards that you may know. Maybe interesting for you to know as well, there will be a European standard for ductless fume hoods. Hopefully it will be published soon, which will be a combination of the Chinese standard for ductless fume hoods and a combination of the French one. Again, if we talk about containment, because that's what this is all about. It's about minimizing the risk. So this air barrier that you have between the chemical products and the person in the lab must be tested as well on a ductless fume hood. So how do we do that? We apply exactly the same protocol that is performed on a ducted fume hood, which is part 3 of the EN 14175. So what do we do in a ductless fume hood? We are going to test again with SF6 and see if there is less than 0.1 ppm of that chemical released in front of the user. And we are going to check as well what the airface velocity of the fume hood is. And the airface velocity is the airflow through the cabinet, and it must always be between 0.4 and 0.6 meters per second when you have a fixed opening. If there would be a sliding sash opening, it has to be higher than 0.4 meters per second. Otherwise, you have a risk of the chemicals coming to the people or the person working with the hood. As I mentioned, you have two ways in which you are protected. You have the air barrier, so the containment, but also the chemicals, they have to go somewhere. On a ducted fume hood, they will be extracted to the outside air. On a ductless fume hood, they will be captured by an activated carbon filter or by a HEPA filter. Just to give you some more information about how we test that, this is a test that we perform in order to know that there are no chemicals released after the carbon filter. So after the air has passed through the filters, that's how we know that you are in complete safety. So these are tested, for example, in the lab here at our lab by our R&D department with isopropanol and cyclohexane. And filters for acids are we use hydrochloric acid to test. We are always going to look for a result under 1% of the exposure limit value of the product that is released or that is used in the fume hood. So that's just to give you an idea that we not only have to test the containment, but we also have to test the filter efficiency and the way the way the chemicals are or the filter, the activated carbon filter is his performance is tested. So to sum up again, for a ductless fume hoods, there are numerous advantages, which is of course the fact that it's mobile, it's flexible, it's plug in and play. It comes in, you put it on your table, and you can work. It's operational, so it's very easy to relocate. The energy consumption is very low, and that's thanks to the fact that you're not going to consume any air, so you're only going to use the air present in the laboratory. And so there is no planification, there are no works to be done. For a ducted fume hood, you have to think about the infrastructure, the connection to the HVAC, etc. With a ductless fume hood, that's not the case. the only inconvenience of a ductless fume hood, and that's why risk assessment again is so important. Know exactly what you're doing in those hoods, is the fact that huge evaporations are not allowed, because otherwise the carbon filters will be saturated very quickly, and then we cannot guarantee the safety of the people working with the chemicals. Of course, what we saw again in the list of safety solutions, these are some other solutions that are used in labs: glove boxes, isolators, articulated arms. For people who use those in the lab, it's important that you know that articulated arms have no containment, so there is really no, there is an extraction to the outside air, but there is no containment, which is really important for you to know. Maybe it's an interesting idea to then look for a better solution. So again, risk assessment, evaluating the risk that you're exposed to, and taking the goods, or looking at the best solutions that keep you safe. Biosafety cabinets to protect yourself from microbiological risks, which are of course a lot in demand during the corona crisis, and also storage cabinets, of course, that have to be ventilated in order to store products correctly, and that will release chemicals in the storage cabinet. So we talked about technical solutions, products, hoods that you can use in order to keep you safe. The things that you can do as from tomorrow in the lab are good practices, training, information that you give to the people who work in the lab. And that's something really interesting, and that's something that we do when we visit our customers over and over again, is just to tell them, this would be better if you do that, this would be better if you do that. And those are always simple things that people are not always aware of that they have to be reminded of those good practices in order to work safely. So just to give you an example, on the picture here, you see my colleague working with a ducted fume hood. And so actually the door of the fume hood is completely open. Of course, that's not a safe way to work with a ducted fume hood. Of course, it's the easiest way. It's very handy to work with an open door, but there is a false idea of safety when you do that. So really do not open the door, because the airface velocity will be too low. So of course, never block the internal value of the enclosure. The containment is only really efficient if you don't disturb the airflow, so the airface velocity. Work with a distance from the front opening, and do not introduce, of course, your head inside the enclosure, as my colleague here on the picture is doing, which is not really a safe way to operate. So these are a few good practices when you work with a fume hood. Some other do's and don'ts is, of course, check the compatibility of the products that you're going to use with the hood or the material of the fume hood. Which the fume hood, for example, has a Trespa worktop, or a tempered glass worktop, or a stainless steel one. These materials will react to some chemicals. So think about that as well. Which chemicals am I going to use? And are the materials in my safety solution, are they adequate? Are they not going to be damaged by using these chemicals? That's important. Of course, avoid cohabitation of flammable solvents and heated or bases. It's important not to combine some chemicals in the fume hood when it's not necessary. Cover containers as much as possible, because then you have less evaporation. And also it's important to cover containers just to evaporate less products, so you don't have to buy over and over again chemical products. Do not use it as a storage area. If we talk about ducted fume hoods or ductless fume hoods, never use a fume hood as a storage solution. Of course, in a ducted fume hood, you will saturate the filters, and in a ducted fume hood, it will consume a lot of energy. So always store them in a ventilated storage cabinet. And of course, very logic, keep safety markings visible and inspect regularly the functioning. Installation, very important as well. As I mentioned, when you were talking about containment, the airflow, the airface velocity can be influenced by people who pass just alongside the fume hood. So it's really important that when you work with your safety solution, when you have these ventilated enclosures, is that you try not to disturb the airflow. And how can you do that? By applying these good practices, by installing the fume hoods away from a table, away from a closed wall, by informing your colleagues that they cannot pass behind you just at less than 1 meter, for example. These are things that are obvious, you may say, but it's really important just to think about that. So if you have a fume hood yourselves in the lab, check that if it's really applied. One of the things that is often that we often get from our customers is that doors or ventilated or the exhaust system is just on top or next to the fume hood, and so you get an alarm of the airface velocity which is disturbed, and often it's related to a door which is too close or a ventilated exhaust system which is just on top of the fume hood. So then, of course, maintenance of these safety solutions is as well very important. The airflow indication has to be checked. The anemometer and inside fume hoods has to be calibrated each time again when you change, for example, a filter. You need to make sure that the maintenance on the safety solutions is well done, and it's not done only during commissioning, but it's also done afterwards, after 1 year, after 2 years. So very periodically, make that a habit. When you use the methodology of risk evaluation or risk assessment in the laboratory, write that down. Say yourself, okay, we make a planning. Every year we do this. We check the maintenance on these different safety solutions, and we do that according regulations. For example, the EN 14175. What are the different tests that we have to perform? Do we have to ask a supplier to do that? So think about all those things and never take safety for obvious, of course. So containment, airspeed, lighting system, things you have to check in order to minimize the risk, in order to keep people safe in the lab. So then again, for fume hoods, at the reception, look for a good installation. When you install, for example, filters that have captured toxic powders, you need to know the procedure to change those filters. Yeah, it's important to think about those things and to look for the best way possible to minimize the risk. So to finish the webinar, which took almost around 40 minutes, I hope you've all enjoyed the information, but never take safety for granted. That's the most important thing. Never take safety for granted. Look for the best way possible to protect yourself. Do risk assessments when you buy safety equipment. Never underestimate the things that you do in the lab, but never overestimate as well. Never be too enthusiastic about all the safety that you have in the lab. I think there can always be something that can be done better in the lab. So yes, do a risk evaluation. It's a subject, it's a topic that will always come back. I'm sure that we here at EURLab, we will do more webinars about safety in the lab. We will also think about more topics to include in the webinar. So your feedback is always greatly appreciated. And so I think I will pass the word to Manuel if any one of you people have questions about any slides that I spoke about or any different topic that I said. So Manuel.
So I think you can now see both of us. I hope so. So thank you, Moraine, for this presentation. We do have questions actually that we had during the presentation. The first question is from Vrindrich Vidanes. Sorry about the spelling of the name, the pronunciation. What type of biological safety cabinet do you have? So,
sure. So, well, EURLab, we are specialized in. Manuel, can you skip your?
yeah. I think the people do hear you.
Yeah, but I hear you as well. So can you?
Ah, okay, sorry.
Sorry, everyone. That's just a technical issue. So to respond to your question, we as EURLab, we are specialized in ductless fume hoods. So we are specialized in manufacturing solutions with ductless systems. So we have enclosures with ducted, with molecular and particulate filters. We don't manufacture PSMs or microbiological safety cabinets. That is done by other companies. Because a microbiological safety cabinet will protect not only the user, but will also protect the samples inside the enclosure. So there is a double protection for the people who work with, for example, things that are viruses, for example. You need to protect the people outside in the lab, but you also need to protect the samples inside so that there is no cross-contamination, for example. So that's that's a biosafety cabinet, and we don't provide that as EURLab. Yes.
Thank you. I hope it answers the question you had, Vinrich. So the next question is from Marife Antonio. What do you suggest in the lab if they are using hazardous chemicals? Which is better, fume hood or laminar flow cabinet? So I think you have to explain the difference. And Marife Antonio would also like to know if this is possible to get a copy of this presentation. So this is possible, actually. I think the presentation is going to be on the website or on the LinkedIn session, on the LinkedIn page, so that you are going to be able to download it. So I will check it with our marketing department. So Lorraine, if you want to give the answer to the question.
Sure. So the difference is we've only had 45 minutes to talk about the few solutions that we offer, or a few solutions that are keeping or at minimizing the risk in the lab. So we talked about ducted fume hoods and ductless fume hoods mainly. So we did not talk about laminar flow cabinets. And why is that? Because laminar flow cabinets, they don't they're not dangerous for the people in the lab. A laminar flow cabinet is going to protect the sample inside the cabinet. So if you have a sample that needs to be in a clean air enclosure, the airflow will be the other way around. So the airflow will not go away from you. No, the airflow will go towards the user. So if it goes towards the user, of course you will never use chemicals inside the enclosure. So a laminar flow cabinet is used to protect the samples, and a ductless fume hood or a ducted fume hood is used to protect the user for chemicals. So I hope that that is an answer to your question.
So I just wanted to add something actually to clarify the wording of all these units, because a lot of people ask for fume hoods, ask for laminar flow cabinets, ask for PCR workstations, and biological safety cabinets class 1, class 2, class 3. So Moraine was pointing the fact that the best question, as you said, was to ask yourself, do you need to protect the user, or do you need to protect the samples or the products? And then the solution will be different, of course. So we have another question from Vina Rose Ambas. Do you need ducted fume hoods for a hazardous chemical you handle, or just one unit of hood for the whole laboratory? What if a lot of chemicals are being handled at the same time?
So, of course, when you use a lot of different chemicals in the lab, you will not be able to use all of them at the same time in the same enclosure. So what we recommend is, of course, look at what's the most useful for you. When you work in the lab, of course, the first thing is safety. So you need to think about safety in the first place. But of course, as well, what's the best way to operate? What's the most easy way to do your manipulations? However, ducted fume hood will will keep you safe with if you use it in a good way for the chemicals that you're using, and it won't have any problems by replacing a filter. For example, you have an unlimited amount of chemical vapors that you can release in the fume hood. However, you're going to consume a lot of chemicals, and you can be exposed to it if you're going to move it outside the cabinet. So a fume hood, of course, the ducted fume hood is a really good solution, but you're not going to use obviously many different types of chemicals inside the enclosure. And as well, what's important is there is a you have a limited HVAC capacity, so you won't be able to install, for example, 10 ducted fume hoods in the same laboratory, because the HVAC system has to evacuate all these fumes from these 10 fume hoods, and that's just not possible, or very difficult if you don't have the appropriate system. With a ductless system, you don't have a limitation. These are standalone systems. You can place as many as you want in the lab. So that's a really big difference to make between a ducted system and a ductless system. So thank you for your question.
So we also received another question which is related to this topic from Vasily Mitz, who says and asks, ductless fume hood is not intended for huge fuming, but how much fuming is considered huge? Are there any numbers?
Well, that's a really interesting question, because we as experts in molecular filtration or in ductless fume hoods, of course, we need to estimate. We need to know what you're going to do in the fume hood in order to say, okay, this filter will keep you safe, so it will absorb all the chemicals that you're using in the fume hood. And secondly, it's very important to know what are you going to do with those chemicals, which quantities are you going to use, because for different chemicals, the filters will have a different retention capacity. So I cannot I cannot give you a straight answer saying this is the the filters will retain that amount of chemical. So it's really a question of doing a risk assessment with us by filling in, or by giving us the information about your manipulations, about the frequency of use, about the quantities, in order to provide you an appropriate solution. In order to provide you with the information, you need to replace the filter every 8 months, every 12 months, every 2 years. It's all depending on what you're going to do in the fume hood, and that's an exercise that we do together with you.
So I think this this answer did also answer to one question from Rachel Parkin, because you asked how long does a ductless fume hood filter last if being used for 4 hours per day. So this is not possible, as Moraine told you, to give you this answer without performing a risk assessment, because we also have to know which kind of product you are going to use for 4 hours per day, and the time you're going to, the exposure time is not going to be the only parameter we are going to take into account to do the risk assessment. So the best way to get your answer, all your answers actually about the questions for how long, how many, and how much product can I use under the fume hood, is to perform this risk assessment. We provide, this is free of charge, and we will be more than glad to help you and support you with your project. And our our technicians in the lab are going to be able to provide you with a lifetime expectancy. So there is another question about when the filters of the ductless fume hoods have been spent, should they be considered as hazardous materials, and what is the best method for their disposal? And this question is from Giancarlo Reyes.
Hi, John. Thank you for your question. A really good question as well. What do we do with filters that are saturated, that have to be replaced? So of course, this is considered to be chemical waste. Activated carbon works in a way that it will adsorb the different chemicals, the different molecules that are released inside the enclosure. And once the carbon is completely saturated, it means that all the different carbon particles have completely absorbed chemicals that are released into the enclosure. So what do you do with that afterwards? There's different companies which will incinerate them and use it again to use the energy of the incineration afterwards for other things, other practices in their company. So that's something that is done. Otherwise, we have a lot of customers who dispose the filters themselves through their proper chemical waste system or company. We in France, for example, we go to our customers and we pick them up. We pick them up ourselves and we send it to a company called Veolia, who is going to incinerate it and is going to use the energy of the incineration for other things in their company. So I hope this is a question on your this is a response on your question. But of course, you will never reuse a carbon filter. That's for sure.
So thank you for your explanation, Marijn. So another question from Eddie. Eddie asks, can we use acetone only to test both acid and solvent fume hoods? So actually, I do not understand what you mean, but
I think so. So if I will try my best to reply on your question. We of course I've shown on one of the slides. I've shown you what the procedure is in order to test the efficiency of activated carbon filters. So it was mentioned that it's with hydrochloric acid that we're going to test the activated carbon filter. However, we do when we sell a fume hood to one of our customers, we always recommend them to do a test with acetone, exactly, because acetone is very volatile. It's a chemical that we find in most laboratories. It's very volatile, so it will go up, or there will be some chemical vapor straight away, and we can test it easily by using a colorimetric tube or by using the sensor, which is also in place in the fume hood. So yes, you can use acetone because the filter, the activated carbon filter that we have for acids is also a filter which will filter solvents, so it will filter both solvents and acids. So of course, if the acetone goes through the filter, it gives you as well an indication about the capacity of the filter to absorb acids. So yes, you can use acetone.
So I hope it answers your question, Eddie. And if it doesn't, so please just let us know writing on the chat interface or questions interface. Another question from Joseph Chan. I saw in your slide that Airlab uses HEL to test the ductless fume hoods with BE filter. May I know what device or method do you use to detect the breakthrough acid?
Really interesting question. Thank you very much. What we developed at Airlab, we work on three main things when we develop. We have an R&D lab here with 15 enthusiastic people who develop new filters, new equipment, always ductless. What we do at Airlab, we work on filtration, of course. So we develop molecular filters and we try to increase their retention capacity. But we also developed three sensors which will detect the saturation of the filters that are installed in the fume hood. So the sensor comes after the first layer of activated carbon. So one of the sensors is adapted for acids. So it will detect three types of acids, and if you would like to have a bit more information about which one or which acids that you use, again, we do the risk assessment. But yes, we have a sensor that detects acids in order to give you a signal that the filter has been saturated. But that's also a recommendation that our lab does after having performed the risk assessment.
Oh, thank you. Joseph, just another information, because you asked the type of device we use. This is an electrochemical sensor with three threshold values that we use. And if you wish to have more information, do not hesitate to contact us and we will give you all the technical details you may need. So Eddie could just confirm me that it was okay, your answer. So thank you, Eddie, for confirming.
Thanks.
I think we had new questions. Ana Maria Chupunko, sorry. So it's very funny because we are not allowed to travel right now, but we really do. Thanks to you guys with Moraine, we really do have the impression to be traveling all over the world right now. So thank you about this.
Maybe something to add about that, Manuel. Yeah. So just for your information, everyone, can you mute your microphone, Manuel?
Yes.
Thanks. Just for information, we have really a lot of different participants, and it's really a pleasure to do this webinar. We have people from the Netherlands, we have people from Belgium, Portugal, United Kingdom, the Philippines, Vietnam, Thailand, Indonesia, Greece, Lebanon, South Africa, China, Malaysia, Tunisia, Kenya, Croatia, Macedonia, Ireland, Turkey, Ukraine, India, Sweden, Singapore, and Egypt. So we have 24 nationalities present on the webinar. So it's a real pleasure to give this to you. So thank you very much for your reaction.
So thank you, Moraine. He gave us, he made us feel like Eurovision right now. So another question from Ana Maria Chupunko. Do you provide testing services of Fumehoods that are existing already?
So of course the testing, it depends. What we do at Eurlab, we can provide activated carbon filters on existing cabinets which are not which don't have the brand from Eurlab. So we do provide filters for those. The testing on those fume hoods, we don't. So we will only test fume hoods from our own brands, so from Eurlab, during commissioning or when we replace the filters. But on other devices, it's not always an easy thing to do because they sometimes have other regulations. They are constructed with different materials. So we don't do the tests on different brands or different types of fume hoods. So the answer is no. However, if you have a fume hood from another brand, we can propose our filter technology, and so we can do a risk assessment with you to know which type of filter you need on the cabinet which is not an Eurlab brand.
Ana Maria, I would like to add something. So we do not provide testing services on our own, but we do have all over Europe and worldwide a network of trained companies which are actually our official licensed companies, which are able to provide you with commissioning, mounting, and services of the hoods, of new hoods, and of existing fume hoods. So we do not provide these testing services on our own, but we, depending on where you are on the planet, actually, we can provide you with a company which is going to be able to help you, that we trained and certified. So a new question, you're welcome. A new question from Giancarlo Reyes. Can your solutions withstand open flames? Example, we may use benzene burner or alcohol lamps for some procedures.
Well, it depends again on which type or what you're going to heat. In that case, you can use a benzene or you can use gas. You can have access to gas inside the enclosure. So yes, you can use a benzene burner inside the enclosure. However, when we talk about heating, and we talk about flames, and there is often the question of, okay, how much is evaporated in the end? So how many chemicals are coming free? When you heat something and look at boiling water, of course, everything comes free. So in those cases, we are very precautious in recommending our filtration technology, because often the evaporated amount is very high, and then the filter will get saturated quicker. But it is possible. Again, we need to perform the risk assessment in order to know if it is a safe solution or not to use a ductless fume hood.
Thank you. So the last question is there from Marife Antonio. Is there a way to know or remind the user that they need to change the filter?
Well, when you need to change the filter based on our recommendations. So our laboratory, they are going to calculate the lifetime of the activated carbon filters. But yes, as I said, or as one of my responses on one of the other questions about the acid sensor, we have 3 sensors which you can place after the first layer of carbon filters. So these sensors will detect the chemicals coming through the first layer of carbon filters. Our laboratory will as well look into the list of chemicals that you use to look for the one chemical that is going to saturate the filter in the first place. And that chemical will be detected then afterwards by the sensor. And so if the sensor detects any chemicals, it will give you an alarm. And just to give you another information, the sensors are very sensitive. They will always detect chemicals below the exposure limit value of the chemicals. So we tested those sensors here at Lab to make sure that they detect under the exposure limit value of the chemical. So yes, these sensors are available, and we have that solution. And maybe something to add as well for the people who don't know, because of course this is not a presentation about Ductless Fumehoods, it's a presentation about safety in the lab. But if you would like to have some more information about the Ductless Fume itself, we can give you a presentation yourselves directly. But we also have a system of 2 layers of carbon. So you have the first layer of carbon and you have a backup layer. So if there is a breakthrough and you have the sensor which gives you an alarm, you're still protected by a second layer of carbon filter, which is on there. So that's also a way of minimizing the risk again for the people who work with the chemicals in the lab.
So we had in the meantime new questions. So sometimes we need to use chemicals in biosafety cabinets due to the samples. Is it possible to add chemicals filters to such cabinets? It's a question from Sean, I'm sorry, Baldacchino. And I won't tease you, but the answer is no.
So the answer is no, in a way that of course you can use filters inside the biosafety cabinet, of course, but yes, it's just the biosafety cabinet is used to protect the sample and the user, and it works in a completely different way. However, you can have filters, but it's mostly also extracted to the outside air.
Thank you. Another question from Joseph Chan. Can I manipulate mercury in trace amount in the ductless fume hood? It's not allowed to be used in ducted fume hood. Sorry, late question. Don't apologize, Joseph. We are still here, no problem.
Well, I think I remember that mercury is not a product that is filtered by our filters as well. So if in your country it's not allowed to use it in a ducted fume hood, I'm afraid it's not applicable, or it cannot be used as well in ductless fume hoods, because it's not filtered by your lab or by the molecular filters that we developed. If you may be interested, some of you, we have a chemical listing, which is a small book in which we have all our expertise written down. So we tested over 700 chemical products inside the R&D department of Lab. Of course, we don't know by heart all the products, but mercury is one that we know that it's not filtered by our carbon filters. So, but if you are interested in that little book, the chemical listing, please ask and we'll send it to you.
So thank you, everyone. It was the last question. So thank you, everyone, for participating to this presentation. We were almost 110 people. So it was really great having you all. I had the confirmation in the meantime from our colleague, the head of the marketing department, that the presentation is going to be downloadable on the website www.airlab.com. So do not hesitate to contact us, and please all enjoy your weekend and stay safe in this difficult time, and we will see you soon on the Airlab TV, and have a nice day. Thank you for your participation. Bye bye.
Thank you very much, everyone. Cheers. Bye-bye.
Bye.